Okay, so this video takes us the next step. So we've been doing long division in class. And long division, keep in mind the whole reason we were doing long division was to allow us to take take the beginning steps in getting a polynomial that was in standard form eventually into factored form, because it's a lot easier to graph a polynomial in factored form than it is in standard form, because of course we know that factored form gives us the zeros. So synthetic division is another way that we can do division, and it tends to be a quicker, more efficient way to do division, and it's going to help us decide quicker whether or not what we're dividing by is a factor of the polynomial. So we're going to see that in play in just a moment. But there's one key thing you need to know about synthetic division, and it's this. Synthetic division can only be used when the divisor is linear. For example, if it's in the form of x minus k, notice there's no exponent on the x. This is of degree 1, so the divisor has to be of degree 1. If it's anything greater than degree 1, you have to use long division, but synthetic will work for this. So here's a question. Okay, let's say, for example, we want to divide the polynomial 4x cubed minus 5x squared plus 3x, oops, that's a 3, minus 7, and we want to divide that whole thing by x minus 2. Now, let's make sure that the divisor is linear. Yes, there's no exponent on the x, so we can divide it by x minus 2. Okay, now the way synthetic division works is we're going to turn division on its head. So where our divided by sign used to look like this, we're going to use an upside down divided by sign. And then everything else kind of goes upside down from there. Watch what I mean by that. Okay, so we're going to do an upside down divided by sign. It's going to look like this. And then within this divided by sign, we're going to put all the coefficients from our polynomial. We're going to put 4, leave a space, negative 5, leave a space, positive 3, leave a space, and negative 7, leave a space. Okay? The next thing that we're going to do is we're going to divide by whatever was our, what we call our k value. And we're going to choose, instead of x minus 2, because we're dealing with zeros and we're dealing with opposites, we're going to choose a k value of 2 in this case. Because it was a minus 2 there, the actual value that we're subtracting is going to be 2. So this changes signs. This becomes a positive 2. All right. Now, your very first step is you're going to take this 4, you're going to draw him again down here. And this gets us started. This is just our setup. Now, because I've taken the divided by sign and flipped it on its head, I've done the opposite. This is now, even though it's called synthetic division, we're actually going to be doing some multiplying. So all the operations become upside down as the sign went upside down. So what we're going to be doing is we're actually going to multiply this k value right here, we call it our k value, by the values down here. We're going to multiply. So let's do that. So 2 times 4 gives us 8. And we're going to write that 8 over here. And he's going to work with this negative 5. And then, instead of subtracting like we did with regular division, we're doing the opposite because we flip this sign upside down. And so we are going to add negative 5 plus 8, which of course gives us 3. Then we play the game again. We go back to the k value. 2 times 3 gives us 6. And then we're going to add. 3 plus 6 gives us 9. We do it again. 2 times 9 gives us 18. And then we're going to add negative 7 plus 18 gives us 11. And I'm going to put this 11 in a little box at the end. Because what we have in here, the very last term that you come up with, is going to be our remainder. Okay? Since this remainder is not 0, therefore we know that x minus 2 is not a factor. We'll talk about that in just a second. So let's summarize what we've got here. Okay, so we know that now 4x cubed minus 5x squared plus 3x minus 7, that whole thing divided by x minus 2 is going to give us an answer of 4x squared. So it's going to be one less degree because we're dividing by a degree of 1. So x cubed divided by an x is going to leave us with the x squared. So everything's going to go down a degree. It's 4x cubed plus 3x plus 9 with a remainder of 11. And if you remember how we write our remainders, we say, oh, well, what that would really be is 11 divided by x minus 2 if we could do that. Okay? Another way I could say that is I could use just this to make it easier. I could say, therefore, the quotient is, okay, 4x squared plus 3x plus 9 plus 11 over x minus 2. And that just saves you a little of space when you're writing. Okay, just like in long division, in synthetic division, there is a crazy thing that can happen, and we need to talk about what that is right now. And the crazy thing that can happen is if we're dividing by a divisor that's in the form ax minus k. So the last question we did had just x minus k. This one has ax minus k, which means we have a coefficient in front of our x. And it really causes a bit of a sticky situation. So we're going to go through an example of how we're going to do that. So let's start with the example. The example is if I take 6x cubed plus 5x squared minus 16x minus 10, and I take that whole polynomial and I divide it by, and here it is, the crazy thing, 2x plus 3. Uh-oh, we have a coefficient in front of here. And the way synthetic division works is we like to divide by the k value. But the k value has to be in factored form. So let me tell you what I mean by that. So right now, let's take a look at just the divisor. So the divisor is written as 2x plus 3. And what I want to do is I want to factor out that coefficient. I'm going to factor out the 2, and I'm going to be left with x plus, and when I factored, the 3 becomes a 3/2 because I've divided by that 2. So this guy right here now, this is our k value, and that's what we're going to use when we do synthetic division. Now, because it's a crazy thing, not only is this going to be our k value, but there's going to be a second step, and we'll talk about that second step in just a second. All right, so let's set up our synthetic division just like we did before. So we have our upside down divided by sign, and I'm going to write the coefficients of each term. So I have a 6, I have a 5, I have a negative 16. Notice I don't have any missing powers. I go 3, 2, 1, 0. If I did have a missing power, I would have to put in a dummy term, just like I did in long division. Okay, let's finish this off at negative 10. And again, I like to put a box here just to remind myself that whatever in the box is going to be the remainder. Then in front of here, this is where I put my k value. And the k value, of course, is this value here, but the opposite of it. So it's going to be negative 3/2. All right. So we started off by taking this 6, writing it down there, and this guy gets us started. And remember, even though it's synthetic division, we flip the sign, so now we're actually doing multiplication. All right, so now I do the multiplication. Negative 3 times 6 divided by 2 is what this is going to turn out to be. So it'll become negative 18 divided by 2, which will turn out to be negative 9. Then I add my 5 plus my negative 9, which is going to give me down to negative 4. Go back to the k value and do it again. Negative 3 times negative 4 divided by 2, which gives me 12 divided by 2, which gives me 6. And I add these, and negative 16 plus 6 gives me negative 10. Or, yes. There we go. And so negative 3 times negative 10 gives me 30, and 30 divided by 2 gives me 15. And then I add these again, and negative 10 plus 15 takes me up to positive 5. So my remainder is sitting in here. I have a remainder of positive 5. Now, here's that second part to the crazy thing that you have to do. The second part is we haven't considered this 2 yet. All we've done is said, oh, if I divide it by x plus 3 halves, but that's not what the question is saying. So in order to finish off this question, the next thing I have to do is take these values that I have here and divide them by 2. But the thing is, the remainder doesn't get divided. It stays the remainder of 5. So, and you can always double check that using long division if you don't believe me. But the remainder does not get divided. He's in jail here. Everything else gets divided by 2. So now we're going to have 6 divided by 2 gives me 3. Negative 4 divided by 2, of course, is negative 4. Negative 10 divided by 2 is negative 5. And the remainder does not divide. He stays a remainder of 5. So therefore, I can say that the quotient answer is going to be 3x squared minus 2x minus 5 plus, and it's 5, a remainder of 5, divided by 2x plus 3. And that's your quotient statement. So again, because we have a remainder, we know then that 2x plus 3 is not a factor because there's a remainder. If I had a remainder of 0, then 2x plus 3 would be a factor, but it's not, so it is not a factor.